All right, the function f is defined by f of x is equal to 1 divided by 1 minus x. You're supposed to write the Maclaurin series for f, give the first four non-zero terms and general term. For what value of x does the series converge? Well, there you go. We talked about that in class, and our interval of convergence is due, well, that was my erdosh. That was due to it being a geometric series. Part B, it says use your answer in part A, so I'll write that. To find the Maclaurin series for f prime of x, give the first four non-zero terms and the general term. For what value of x does the series converge? Well, if I find the derivative of each term and expand out one more and look for a rule, there you go. Now, the only thing is I keep that interval convergence, but I still need to check my endpoints. Checking my endpoints, I plug in an x equals -1. This series diverges by the nth term test. I plug in x equals 1. This series diverges by the nth term test. So still I keep that interval from -1 to 1 to be the interval of convergence for this series right here. Part C, it says use your answer in part B to find the sum of the infinite series. Well, again, 1 plus 2x plus 3x squared plus 4x cubed, yada yada. Well, isn't that just this expression evaluated at 1/3? Why, yes, it is. So I go and I find f prime of x. I was given f of x is equal to 1 divided by 1 minus x. So I find f prime of x, which is 1 divided by the quantity 1 minus x squared, and evaluate it. I think that equals down in the 1 divided by, it's going to be 2/3 squared, 9/4 is the whole answer. Hope that helps. Now, if you look at D, it says use your answer in part A to find the Maclaurin series for the integral from 0 to x of f of t dt. Give the first four non-zero terms and the general term. For what values of x does the series converge? Well, there's my original. Always write it out. The integral from 0 to x of 1 plus t squared plus t cubed, yada yada yada. I employ the fundamental theorem of calculus. That 0 makes life beautiful. So these are my first four terms and then my general term. But I still need to look at this interval of convergence and check endpoints. When I check endpoints, when x equals -1, I get a convergent alternating series. When I check endpoints, I get x equals 1, I get a divergent harmonic series. So now my interval of convergence is as shown. Finally, use your answer in D to find the sum of the infinite series. Okay, well, 1/3 plus 1 over 3 squared times 2, 1 over 3 cubed times 3. Isn't that just my integral from 0 to 1/3 of that f of x? Well, if I take that integral, I get natural log and I value it and I get minus natural log 2/3. Well, if I plug this in here, I'll see that I have a series. What's really cool is if I evaluate minus natural log 2/3, I get that. I take the integral from 0 to 1/3 of 1 divided by 1 minus x, I get that. And then finally, if I were to take the sum of the first 1001 terms of 1 divided by 3 to the n plus 1 times n plus 1, look at that, I get the same term. Isn't